Hey everybody, it's midnight on Friday, and I've decided to make you a video to prepare you for the upcoming epidemiology final exam next week on Tuesday, December 19th, 2017. So in case you're watching this sometime in the future, and it's not 2017, this video does not pertain to you, my friends. Let us begin. So, what did we learn this year? We learned a lot of stuff, I hope we did. I learned nothing because I'm the teacher, but we learned first and foremost a lot about biases, and you had an entire assignment all about bias. So hopefully you retained some of that. We learned about evidence-based medicine. Most of us in health sciences are already something of an expert in evidence-based medicine, but hopefully you learned a little bit more about it, about the hierarchy of evidence, the pyramid of evidence, with RCTs and systematic reviews at the top. We learned a lot, I think, about systematic reviews, and you did something resembling a systematic review for your final poster presentation, and you all did very well, by the way. I'm quite proud of all of you. Some were extraordinary. We learned a lot about types of studies. So the cohort, that begins by ascertaining exposure status. The case control, which begins by ascertaining outcome status. I mentioned nested studies, but we didn't really study those, so don't worry about that. We learned about randomized controlled trials, the quasi-experiment. So the quasi-experiment is like a regular experiment, but there's no random allocation. The ecological experiment, or rather ecological study, is not an experiment. The ecological study is an observational study in which the unit of analysis is the population and not individuals. So groups of things, not individuals. And we learn about something called a natural experiment. And we're going to go through the difference between the quasi and the natural a bit more in a few minutes. We learn a lot about morbidity. Morbidity are these measurements that you hate so much, prevalence and incidence. Remember, incidence, we have cumulative and density. Cumulative is the normal math, and density is the confusing math, in which the denominator is some kind of measurement of person time. Woman years, man weeks, person time. We touched a little bit on dailies, the disability adjusted life years. We said dailies are bad. We don't want dailies. We want a given disease gives a certain amount of dailies, which is a combination of the years of life lost due to death and the years of life spent disabled. Either one of those things is not good. And we learned a lot about mortality. Mortality is death. And there are different ways of measuring death. PMR, CFR, crude mortality rate. We learned about how to standardize for mortality. Remember, direct versus indirect methods. And we learned about something called the standardized mortality ratio, which we only really use for the indirect standardization method. We did something called survival analysis, both simple and the complex. The complex thing was the Kaplanmeier method, but the simple thing was just dividing the number of people who were alive divided by the total who started. We did a lot of work on screening tests, and I hope you learned something there, because screening tests are a fun topic, and it's a little bit of fun stuff you can take into your real life when you read the back of that pregnancy test, which I'm sure some of you are going to take. Screening tests in particular, we looked at sensitivity and specificity, positive predictive value, likelihood ratios, how to predict your pre-test odds, your post-test odds, what that means. We measured agreement, one kind of agreement, kappa. Now, there are lots of kinds of agreement measurements. Kappa is just one, but we did the computations for kappa. We talked at length about validity versus reliability, and we said that they're slightly different for tests like screening tests versus studies like cohort designs and things like that. In general, validity is, are you doing what you said you're doing? Is it valid? Is the thing you're doing in your study, does that have any relationship to the real world? And reliability is reproducibility. Okay. We also talked a lot about causality. Remember the Bradford Hill criteria? How do we know if this causes that? we introduced something called the attack rate, which is just a kind of incidence rate, and that we usually compute for outbreaks. Did a lot of work on relative risks, odd ratios, and a little bit of work on attributable risk. And I hit you over the head a couple times with p-values and confidence intervals. A lot of this is stats review, I know. But epidemiology is mostly basic stats, in some people's opinions. We mentioned randomization, and I showed you two kinds of ways of doing it. Simple randomization, which is coin flipping, and block randomization, which seeks to attain a parity, sameness in the sizes of people, numbers of people in study arms. Okay, your exam, my friends. Your exam takes place in a few days on Tuesday, December 19th at 7 p.m. Look, I know you're complaining, but I got to be there too. So this doesn't make me happy. I got to spend my Tuesday evening in the exam room. At least you're writing an exam. I got to sit there and be on Facebook complaining about you. So it's not that much fun for me either. I want you to bring a calculator. Every year, in every class I teach, someone's calculator fails. And they always say, Professor, do you have a spare calculator? No, I don't have a spare calculator. That's not my job. You make sure your calculator works. Make sure it's got a battery in it. And make sure it does what you need it to do. It's happens every year like clockwork. Someone's in tears. My calculator's not working. You got several days to figure this out. Figure it out. Your cheat sheet. Okay, we've talked about the cheat sheet at length. And every year, I tell you, it's just a piece of paper, 8.5 by 11, write on both sides, either side, print, write, photographs, I don't care. And yet, without fail, somebody emailed us, Professor, is it okay if we print on the cheat sheet? Yes, it's okay. It doesn't matter. And of course, bring your bribe. I said I accept all major currencies. Now, I prefer Bitcoin. So if you can pay your bribe via Bitcoin, I'm joking, people. It's a joke. Someone's parents going to see this and say, the professor is taking bribe. No, I'm not taking a bribe. Just relax. It's a joke. So the exam is cumulative, if you have not figured that out already. That means everything is fair game. Why? Because you're in fourth year, okay? Suck it up. This is the way the world works. There are a total of 95 questions. In previous years, there were over 100 questions. I have gradually reduced the number of questions, which bothers me because it means students are increasingly incapable of doing the same questions I've been asking for years. Maybe I'm teaching it more poorly every year. I don't know, but people are stressing out because there's too many questions, so I took some questions out. There are 95 questions total. Most of them are theory questions, meaning you don't have to compute anything. It's just bleh. Okay, about a third, 29, are calculations, and there's a bonus question. So the bonus question means that if you get it wrong, it doesn't affect your mark. If you get it right, you get one extra thing. So bonus is good. Bonus. That's why it's called a bonus. All the calculations, pretty much, and I've said this before, it's just dividing two numbers. The math isn't hard. The hard part is figuring out which two numbers to divide. That's it. Okay, it's all intellect. It's not math. It's intellect. So, as you know, this is worth 40% of your final mark, which I'm sure terrifies some of you, but that's the way the game is played. Terror. It is based entirely on the stuff in class, and by class I mean videos as well. The textbook is there to give you examples and to clarify issues. If I did not mention it in class, it is not on the exam. So anything new from the textbook is not on the exam. So I would use the textbook for practice and context, not for core content. And I think by now I will have uploaded some additional practice questions. You can try those out. And remember, I will answer no questions 24 hours before the exam, which means 7 p.m. on the 18th, I will ignore your emails from that point on. And somebody always tries, but Professor, can I one that? No, no more. Okay, and the reason for that is there's always a bunch of freaks, some anxiety-ridden freaks who just freak out like an hour before. No, I can't deal with that. So figure your shit out before 24 hours. So it is all multiple choice. You know that. You know I'm a lazy bastard. And again, the cheat sheet can have whatever you want on it. Do not ask me again what you can put on the cheat sheet. The answer is anything. Anything. A burger, that's fine. Anything you want. So there is no Kaplanmeier stuff on the exam. Yay! And the reason for that, of course, is, as you know, I'm traumatized by Kaplanmeier. I don't know why. I find it problematic. There is no chi-square calculations either. How convenient is that? Mostly because I think I forgot to add it, but, don't worry about the chi-square stuff. What to stress? Stress the pluses and the minuses of study designs. Which designs are good for these scenarios? Cohorts are great when the exposure is rare. Case controls are great when the outcome is rare, etc. Know your biases. And by biases, I mean all the good stuff. People are obsessed with Bergson's bias. I've got like 12 students go, Professor, is this forget about Bergson's bias. Maybe there's one question. I'm not saying there is, but if there is, there's probably one question on it. So don't spend all your time worrying about Bergson's bias. It's just one. There's a host of other ones we talked about. We talked about the Texas sharpshooter fallacy. We talked about a bunch of other stuff. We talked about confounding a lot. Now, confounding is not technically a bias, but I want you to know what it is and know how to interpret it. Confounding is a big part of epidemiology. Effect modification we talked about. We talked about this thing called regression to the mean, which means that if we observe an extreme event, next time we do the analyses or the experiment, we won't see as extreme an event. Things tend to regress to the middle somewhere. We did a lot of work computing odds ratios and relative risks and attributable risks. And again, I said it before, the math is easy. The hard part is extracting the information from the question to divide. That's the challenge. A lot of screening test stuff, so know how to do your sensitivities and your specificities and your PPVs, blah, blah, blah. As I mentioned, 29 computations, 66 theory questions. Does that add up? That adds up, right? And you have a total of 3 hours. My advice to you, in the past, the people who have struggled, and not everybody has struggled, a handful have struggled, but those who have struggled over how to create the proper contingency table from the scenario presented. Remember, each question is worth the same amount. So if you're spending half an hour doing one, don't. Move on. It's just one. Spend your time elsewhere. But if everything's done and you got a question that you can't figure out how to make the 2x2 table because everything is 2x2 tables, practice that shit, man. Just get it down. That's key to those questions. Some sample questions. Which of the following is false? A, the attack rate is a type of cumulative incidence rate. That's true, my friends. That's a true one. Inter-rater reliability is a measure of agreement. Yes, it is. The daily accounts for both mortality and morbidity. Yes, it does. Years of life lost, morbidity, and years of life disabled, mortality. An incident rate cannot be computed from a cohort study. Bam, 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 wrong. Cohort studies are innately able to produce incidence rates. So the answer is D. What's the difference between a natural experiment and a quasi-experiment? All right. An experiment, by nature, is something in which a study involving variables manipulated by the investigator. In a quasi-experiment, there is no random allocation of people. The example I always give is a radio broadcast to this town and this town not receiving the radio broadcast. You can't see my hands. There it is. This one gets the radio broadcast, this one doesn't, and we look to see if their behavior has changed. Right? So the intervention was the radio broadcast. We did that. It's an experiment. But we didn't tell people which town to live in. They live there automatically. But with a natural experiment, a similar thing happens, except you didn't do the radio broadcast. Someone else did it. They were going to do it anyway. You just showed up and analyzed it. So maybe you have a smoking ban that's been instituted in this town here, and not in this town. And you're going to see whether the smoking ban results in changes in, emphysema rates in both places. So you didn't do the smoking ban, the municipalities did, but you're still going to analyze the difference. That's a natural experiment because you did not, you're not the one, you the investigator are not the one who did the intervention. Hawthorne and Rosenthal effects. What are those? These are biasing effects that have to do with blinding in a randomized control trial. So the Hawthorne effect comes from the Hawthorne Works factory, where they found that if you turn the lights up, people worked harder. That means that if you observe someone, or they know you're observing them, they behave differently. That's essentially what that bias is. And in a randomized control, essentially it means if the people know which drug they're getting, if they are not blinded to whether they're getting the placebo or the control, or the actual drug, they will behave differently. Rosenthal effect is also called Pygmalion effect. That's when the observer treats people differently depending upon if they're getting the drug or the placebo. So Rosenthal and Hawthorne effects are why we have blinding for both the subject and blinding for the observer or investigator. Oh, more sample questions, my friends. How exciting. The heavily controlled nature of some RCTs can imply what? Well, heavily controlled means that the people aren't allowed to go outside. We control their food. We control who they see. We make sure that the only difference between my test group and my placebo group is the drug they are getting. And that's great because we make sure that internally things are quite valid. We know that the effects we're seeing are because of this and this. But that gives us poor ecologic and poor external validities. Because it's so controlled, this does not represent a real-life scenario. So the heavily controlled nature implies poor ecologic validity. Ecologic validity talks about, is our scenario applicable to the real world? So, what did you learn this year that was useful? Well, what didn't you learn that was useful? It was like a smorgasbord of usefulness. You learned about bias. So now when you read the news, you will see bias in action. You learned about study design. So hopefully you can be critical of the studies that you read now and decide whether designs were appropriate. We learned about causation. How do you know when something causes something else? You learn about appraisal. So again, when you read a paper, is it good or is it crap? Hopefully, you're experts now. The nature of knowledge. Epistemology. How did people get what they know? How do you know what you know? I told you, that's why. But ask yourselves all the time, who got this information, how they do so. And data. Okay, hopefully you learned a little bit about the quality of data, where it comes from, and why it's flawed. Oh, more stuff you learned. Well, remember from your poster presentations, you learned about logic. Only ask questions that are rational, and your methods must be tailor-made to the questions. We didn't do decision-making. It's in red here because I didn't cover that this year. But in the past, we did some decision-making analyses. Now you know what you could have had, but we didn't. And evidence. What's evidence? Are you shocked to know the world is not really evidence-based? You're not shocked. You're a bunch of cynical bastards because that's your generation. Cynicism. I don't know. Maybe. Okay. That's all, my friends. I'm sorry I didn't get to really end off the year with a proper lecture. It's a lecture I usually give at the end of every epi class about paradigms. I tell this great story about this time where this magazine asked me to debunk this claim by this Indian mystic who claimed that he could thrive without eating. It's a good story. And it's all about the assumptions we make in science and how very often we are unable to explore really whether or not our own methodologies are fragile and based upon good assumptions. So the takeaway message from that story that I did not tell you is that we must remain humble to the vicissitudes and frailties of our science. We do not have 100% knowledge. Epidemiology is a paradigm. It's a set of methodologies, and they're always evolving. So do not be content with the set of methodologies I've given you. They are not sufficient. They are not complete. They are always changing. But that's philosophy, and you don't care about that now. You care about marks. So see you Tuesday, where you'll get big marks. Maybe. Most of you. Some of you. Well, I know who. All right, good luck. See you later.